Hi everyone, this is a tutorial slash example for an aluminum tube. So the first thing we want to do is check our Fusion 360 to make sure we have both the post processor and our tool templates installed. There are videos for how to do those two steps, but I will show you how to check them here. So you open Fusion 360, you go to the design button top left, and we want to switch to the manufacturing view. And then under the Manage tab, the first one we'll check is Post Library. So you click the Post Library button and make sure to go to Local here on the left. And you want to make sure you see Maso. If you don't, go check out the playlist of tutorials and find how to install the Maso post processor. The second thing is the template library. So that's under the Manage tab as well. You click that. Again, under Local, the key ones to have are aluminum sheet ops, tube ops, and wood Lexan sheet template. The other ones are just for other projects. Again, if you don't have these, there's a video tutorial to go watch and see how to install it. Okay, so now that we're confident our Fusion 360 is ready to go, the next step is to actually go to CAD. So in this case, we're using Onshape, and we're going to select the parts we want to cut out. So the first part we're going to cut out is an aluminum tube, and we're actually going to use this end section because it has a good mixture of features. It's got some pockets as well as some holes. So what we'll do is we'll select it, and you can see in the bottom left, I'll make this bigger. The bottom left of my Onshape, I can see the front rail is selected. I can right click and select export. What's important here is that we export as a step format. It needs to be step. And then for Onshape, we want to say download. And you can give it a naming convention if you haven't already named your part, but I'll leave that the way it is. Say OK. And this will download to my downloads folder. Okay, so now what we do is we jump back into Fusion, and we want to go and open that step file we just downloaded. So top left of Fusion, we go File, Open, and then you want to select Open from My Computer. Go to your Downloads folder, and we can select the .step file we just downloaded. Okay, you'll notice at the top here that it's created a new file. We want to go ahead and save this file. So we've opened the .step, and now we want to save it as a Fusion 360 project file. So if you don't already have a location for like your Fusion stuff, you can go ahead and create it. Doesn't really matter where. I like to keep all the FRC CAM stuff together, but you'll want to save it as a Fusion document. So we'll say save. The next step is to switch over to the manufacturing tab. So top left, we'll click design, and we'll go to manufacture. Okay, now we're ready to get into it. There are three main steps. The first is the setup, then the tool paths, then the post-processing. So we'll start with the setup. Top left button here. Like in most CAD packages, we start top left and kind of move our way right. So we start with the setup. And these tabs are actually in reverse order, I think. I like to start with post-process. So we want to give the program a name. So when we go and post-process it, this will be the file name of the code. So I like to give it a very descriptive name. So this is front rail, we'll say side 1 for now. Work coordinate system. So machine WCS is the work coordinate system. Because this is a tube, and we're going to be using our tube fixture, it's actually very important that this is 2. And what this will do is tell the machine to go use the tube fixture. And we've already got our zeros set up for that. So whenever you're doing tube, it's very important that you use 2 here. Okay, so that's the post-process tab down. We'll go to stock. This is telling the program what material it has to cut away. In the case of tubes, for mode, I like to use from solid. And then you select your part as the solid. And then the last tab is setup. And here, what we're going to do is identify the coordinate system we're using. So I'm just going to orbit this around. There we go. We actually want our tube to be sitting like this. We're kind of looking top left down, and we want to orient it this way because that's how it's going to be in the tube fixture. So we need to define the work coordinate system. And what we're going to do is under orientation, we're going to select Z-axis / plane and an X-axis. So I select this option and it prompts me for a Z-axis. So there's two ways I can do it. I can select an edge that's going up and down, or I can select the plane that's normal to up and down. So I'll click the top of my part. And then it wants an X-axis. And again, I can click an edge that's going in the X, or I can click a face that's normal. In this case, I'll click an edge. And then the last thing is we need to select where our origin is. So right now it's showing it in the middle top of the part, but we actually want it to be in the bottom left corner here, or I guess the top left corner, depending on how you look at it. So what I do is I come down to stock point under origin, and I can click this top left corner here. And that's going to be the origin that we set and has already been set in the tube jig. And that's it for the setup. We can say, okay. The next step is to start bringing in toolpaths. Because we use a lot of the same materials, we've already set up templates for cutting most of the things we need to do. So to use these templates, you right click on your setup one. And at the top here, you can create from template. And we're going to use tube ops, which is short for tube operations. So I select that. And it creates my tool templates. Now, be careful, on some versions of Fusion, it will just pop up as a triangle here, or a little arrow, and it doesn't actually expand it for you. Once you click the Create from Templates button, you may need to expand this little arrow. So the way these tool templates are set up is we've incorporated every common cut that we would do on tubes. And if you don't need them, you can simply skip them and delete them. So we start at the top and work our way down. So the first tool path is small holes. Small holes are anything that the 4mm cutter won't work with. And so you can see we're using tool 2. That's what this T2 stands for. So that's going to be the 1/8 inch cutter. So small holes is anything that the 4mm cutter can't handle. So what we can do is double click small holes, and a bunch of options come up. So you can see here, the tool, we don't need to mess with this. It's the 1/8 inch cutter, tool number 2. The spindle speed and math is already done. We just have to go to geometry, the second tab, and we can just select one of our holes. And because this select same diameter checkbox is checked, it'll go and select all of our holes. So that's all of that diameter. And then we'll also grab these ones while we're at it. The next thing to consider are the heights. These should already be set, but the most important thing here is that the bottom height is measuring from the top of the material down the thickness you want to go. So the thickest tube we have is 0.1. So we go a bit extra just to deal with any inconsistencies in the setup or the material, and you don't have to worry about stuff being left behind. So you just want to check this every time and make sure it makes sense for your cut. And if we look from the front, you can see, and if we zoom in here, this blue line represents the bottom of the cut, and it just sticks past a little bit, which is perfect. That's what we're looking for. Okay, so we can say okay to this, and you can see it's generated the toolpath and we get a check mark. So this is great. The next one is cutout. This is used when we have a notch of some sort, and that's a bit more advanced, so we're just gonna leave that out for now. So we can right click and delete. This part does not have any cutouts. The next one is roughing out the large holes. So that is things like lightning patterns or pockets or bearing holes, anything like that. This toolpath will go in and hog out all of that material. And this uses the 4mm end mill. So it goes a little bit faster than the 1/8 inch. So we can double click our toolpath here. And again, the tool and the settings are already set. We can just go to geometry. And this one, you have to go in and select each contour or pocket. So if we zoom in, we actually want to grab the bottom edge of each contour. And take your time here. The selection can be a little bit tricky, but go and select all of them. Okay, so I've got my 9 pockets selected. And again, we just want to check the heights tab. We go through, it's measuring from the stock top down 1/8 of an inch. That should work out. And the rest of this, I would leave as standard for now. I will point out that because this is a roughing pass, we actually are leaving a little bit of material behind. We're leaving 20 thou behind, and we're gonna clean that up with a contour at the end. So we can say okay and close out our roughing, and it'll generate the toolpath. You can see the preview here. Okay, and this is a pretty good time to stop and save. Fusion can crash and toolpaths are pretty heavy, so it's good to frequently save. Okay, the last toolpath we're going to worry about today is the cleaning up of the contours. So we're going to double click, and again, all the settings are correct. We come to geometry, and you're going to go ahead and select your 9 profiles again. Okay, I've selected all 9 contours, and again, I'm selecting the bottom edge of those contours. And just as a double check, we go to heights, measuring from the top of the stock down 1/8 of an inch. And that makes sense for the material we're using. You'll notice here, there is no stock to leave because we're cleaning up to the final dimension. And we say, okay. And once again, we're gonna save. Okay, so setup 1 is now complete with the 3 toolpaths. What we can do is after saving, we can actually simulate this setup to make sure it's behaving as we expect. So if we click on the setup, right click and simulate, press play here, we can adjust the speed. So it's going to draw the holes first and then clear out the pockets. And then come back and clean up all the pockets. You can see in the statistics tab, it tries to give an estimate, but I find this is not very accurate. We can exit our simulation. The next step is to duplicate our process and cut the same features on the other side of the tool. We cannot just run the same setup on the other side because then our lightning pattern would not line up. And in this case, we might have different hole features. The way we do this is, first of all, we're going to change our name of setup 1 to side 1, and this matches the program name we gave it at the very start. Then we can right click and duplicate, and we get a second setup. So first thing we'll do is rename it to side 2. And then we'll go ahead and edit this setup first. So we go to the main setup. What we need to do is we need to change a few things. So first, post-process, we're going to change this to side 2 so that when we export it, we have the right name. The coordinate system is the same. Excuse me. The work coordinate system offset is the same. The stock is the same, but the axes need to change. So we're going to flip our material sort of like this. Let me just get it flipped around here. We're gonna flip our material in the router just like this. So the corner that was up here is now over here, and this becomes a new part. So we kind of flip around the y-axis. So all we have to do is flip our z-axis, flip our x-axis, and select the new box point. Okay, so we flipped the z-axis, flipped the x-axis, select a new box point at the top left, and now we have our new coordinate system set up. And we say okay, and you can see this is side 2. You can see where the origin is, and this is side 1, which is down there. So for side 2, we need to regenerate our toolpaths. So I'll double click on the small holes, and it's actually figured out that these are the holes that we need to do. So that's fantastic. We can say okay, and that'll regenerate. For the roughing, we will probably need to reselect. So I will delete and go through and select, hold Control or Command click to deselect. And we're gonna select all of the bottom edges. Once I've selected all my contours, gonna do the same thing, just check the heights. Looks good, we're an 1/8 inch below the stock top, which is perfect. We say okay. And we're gonna do the exact same thing for the rough or the cleanup. So deselect and then reselect. And we say, we're gonna check our heights and say, okay. Okay, so now we have side 1, which is the bottom side, and side 2, which is the top, and we've got all of our toolpaths done. So the next step is to post-process, and we wanna do this one side at a time. So we'll select and make active side 1. We'll right-click on it and select post-process. In this window, we wanna make sure we select Masso, and if you haven't used it before, you might need to open up the folder, go to local, and select it from the list. The name should be auto-populated from that setup step we did. And then you want to make sure you understand where the output folder, where the code, which is a .nc file, where that's going to end up. So I've got it in my cam folder, and we can say post. So you should get a message down here saying code successfully posted, and then you can actually view the NC code. I highly recommend you view it. It should open up in a text editor. There we go. And this is the code that gets generated. So then back in Fusion 360, we'll do the same with the second side. So we'll make it active, right click, post process, make sure the naming convention is correct, make sure you selected Masso, and hit post. Okay, so now you can move those 2 NC files onto a flash drive and plug it into the CNC router.